For most of human history, creativity was considered uniquely human. The ability to paint a picture, compose music, or tell a story seemed beyond the reach of machines.
A machine could calculate. A machine could follow instructions. A machine could repeat a task again and again. But create, that belonged to us.
And yet, in just a few years, artificial intelligence has begun creating images, writing articles, composing music, and even generating video. A few words typed into a box can now become a painting. A short prompt can become a song. An idea can become a moving scene.
So how did we get here? To answer that question, we need to go back to the beginning. Long before ChatGPT, image generators, or AI video tools, scientists were already asking a quiet but powerful question. Can language be understood as a pattern?
In the 1940s, a mathematician named Claude Shannon studied communication. He looked at letters, words, and messages not as magic, but as information. He noticed that language is not random. Some letters appear more often than others. Some words are more likely to follow certain words. Some sentences feel natural because they follow patterns we have learned all our lives. For example, if someone says, "The sun rises in the," most people can guess the next word, east. That does not mean we are seeing the future. It means we know the pattern. This idea may sound simple, but it became one of the roots of modern artificial intelligence. Because if language has patterns, then maybe a machine can learn those patterns. Not by understanding the world like a human does, not by having memories, emotions, or imagination, but by studying enough examples and learning what usually comes next.
That idea, predicting what comes next, would become one of the most important ideas in the history of generative AI. Before machines could write, they first had to learn how language moves.
In 1950, the British mathematician Alan Turing asked one of the most famous questions in computer history. Can machines think? But Turing knew that this question was difficult. What does it really mean to think? How do we prove that thinking is happening? So instead of trying to define thinking, he suggested a test. Imagine a person typing questions to two hidden responders. One is human, one is a machine. If the person cannot reliably tell which is which, then perhaps the machine has shown something close to intelligence. This idea became known as the Turing test. It was not about whether the machine had a soul. It was not about whether the machine felt emotions. It was about behavior. Could a machine respond in a way that felt intelligent? That question shaped the future of artificial intelligence. And in the years that followed, researchers began to believe that machines might one day play chess, solve problems, translate languages, and even hold conversations.
At first, the dream was not about machines creating art. The dream was simpler, but still enormous. Build a machine that could imitate intelligence.
In 1956, a group of researchers gathered at Dartmouth College in the United States. This meeting became one of the most important moments in the history of AI. It was there that the term artificial intelligence became widely connected to this new field of research. The idea was bold. If human intelligence could be described clearly enough, maybe a machine could be built to simulate it. At the time, the optimism was huge. Researchers believed machines would soon solve problems that had once seemed uniquely human. They imagined computers that could reason, understand language, and make decisions. But there was a problem. The dream was much bigger than the technology. Computers were slow. Memory was limited. There was not enough data, and many of the ideas were still too early.
But even in those early years, machines were beginning to touch something surprising: creativity.
In the 1950s, a computer helped compose music. This may sound modern, but it happened decades ago. The ELIAC computer at the University of Illinois was used to create a piece of music called the ELIAC Suite. It was one of the earliest examples of a computer being used in composition. The machine was not sitting there feeling inspired. It was not hearing melodies in its mind. Instead, humans gave it rules. The computer followed those rules, and from those rules, music was produced. This is important because it shows that the desire to make machines creative is not new. Even in the early days of computing, people were already asking, "Can a machine help us make something new?" Around the same period, researchers also began working on early neural networks. A neural network is a computer system loosely inspired by the human brain. It is not a real brain, but it uses layers of simple mathematical connections to find patterns. One early example was called the perceptron. The perceptron could learn simple patterns, such as recognizing basic shapes. It was primitive compared to modern AI, but it mattered because it suggested something powerful. Maybe machines did not always need to be programmed step by step. Maybe they could learn from examples. In the 1960s, a computer scientist named Joseph Weizenbaum created a program called ELIZA. ELIZA was one of the earliest chatbot programs. It could respond to typed messages in a way that felt like conversation. One famous version acted like a therapist. If a person typed, "I feel sad today," ELIZA might respond, "Why do you feel sad today?" It seemed thoughtful. But ELIZA did not truly understand sadness. It did not know the person. It did not feel concern. It was using patterns and rules. It looked for key words, rearranged parts of the user's sentence, and replied in a way that felt personal. And yet, many people were affected by it. Some users felt as if the machine understood them. This moment is important because it revealed something we still see today. When a machine uses language well, humans naturally start to feel that there is understanding behind it.
ELIZA was simple. Modern AI is far more advanced. But the emotional effect is connected. A machine speaks fluently, and we begin to wonder, does it understand?
The early years of AI were full of excitement. But excitement alone was not enough. Many promises were made too early. Researchers expected fast progress. Governments and companies invested money. The public imagined thinking machines were just around the corner. But the technology was not ready. Computers did not have enough power. There was not enough digital information for machines to learn from. And many early AI systems could only work in narrow, controlled situations. When reality failed to match expectations, interest dropped. Funding slowed down. Research became less popular. The field entered what became known as AI winter. Not one winter, but several periods of disappointment. This is one of the most important lessons in the history of AI. Progress did not move in a straight line. It rose. It fell. It disappeared from public attention. Then it returned. The dream of intelligent machines did not die. It waited for the world to catch up. By the 1990s and 2000s, three important things began to change. First, computers became much more powerful. Second, the Internet created enormous amounts of data. Third, researchers improved the way neural networks could learn. This combination changed everything. A machine learning system works differently from traditional programming. In traditional programming, a human gives the machine exact instructions. Do this, then do that. If this happens, respond this way. But machine learning is different. Instead of giving the machine every rule, humans give it many examples. The machine studies those examples and learns patterns. For example, if you show a system thousands of pictures of cats, it does not memorize one cat. It learns the patterns that usually make something look like a cat. Ears, eyes, fur, shape, texture. Over time, it gets better at recognizing cats it has never seen before. This was a major shift. Machines were no longer only following instructions. They were learning from data. And as computers became stronger, neural networks became deeper. That is where the phrase deep learning comes from. Deep learning simply means using many layers of pattern finding. One layer may notice simple shapes. Another may notice parts of objects. Another may recognize the full image. This approach became extremely powerful, and it set the stage for modern generative AI. For many years, AI became very good at recognizing things, recognizing faces, recognizing speech, recognizing objects in images, recognizing spam emails, recognizing patterns in data.
But generative AI asked a different question. Instead of asking, "What is this?" it asked, "What could come next?" Or, "What new thing can be created from the patterns already learned?" That is the heart of generative AI.
Generative AI does not simply search for an answer and copy it. It creates new output based on patterns it learned during training. If it has studied many examples of language, it can generate new sentences. If it has studied many images, it can generate a new image. If it has studied music, it can generate new sounds. This does not mean it creates like a human. A human creates from memory, emotion, culture, experience, and intention. A machine creates from patterns, probability, and data. But the result can still be powerful, and sometimes surprisingly beautiful. Several breakthroughs helped generative AI become what it is today. One important idea was the GAN, or Generative Adversarial Network. That sounds complicated, but the basic idea is simple. Imagine two machines playing a game. One machine tries to create a fake image. The other machine tries to detect whether the image is fake. The first machine keeps trying to improve. The second machine keeps getting better at spotting mistakes. Over time, the creator machine becomes better because it is constantly being challenged. This helped AI generate more realistic images. Another major breakthrough was the transformer. Again, the word sounds technical, but the idea can be explained simply. A transformer helps AI pay attention to context. In a sentence, not every word matters equally. Some words are more important because they change the meaning. For example, the animal did not cross the road because it was too tired. What was too tired? The animal. To understand language, a machine needs to connect words that may be far apart in a sentence. Transformers made this much easier. They helped AI understand relationships between words, ideas, and context. This became one of the key technologies behind large language models. The kind of AI that can answer questions, write paragraphs, summarize text, and hold conversations. Then came diffusion models. These became especially important for AI image generation. A simple way to understand diffusion is this. Imagine starting with a picture covered in static, like television noise. The AI slowly removes the noise, step by step, until an image appears. It is almost like watching a foggy window become clear. This process made it possible to create detailed images from text prompts. A person could type, "A castle on a mountain at sunset," and the machine could create an image that had never existed before. Not by dreaming, not by seeing the castle, but by learning countless patterns from images and language, then building something new from them. For many years, these breakthroughs mostly lived inside research labs. Then, suddenly, the public began to see them. AI tools began generating realistic faces, artwork, essays, voices, songs, and videos. Large language models became easier to use. Instead of needing to write code, a person could simply type a request in normal language. Write me a story. Explain this topic. Create an image. Generate a scene.
This was a major turning point. Generative AI was no longer only for researchers. It became a tool for writers, designers, students, marketers, filmmakers, business owners, and everyday people. People could create fantasy worlds, product mock-ups, character designs, historical scenes, cinematic portraits, and eventually, moving video, all from prompts. This is why generative AI feels so different from earlier technology. It does not only help us calculate, it helps us imagine faster.
But generative AI still needs to be understood carefully. It does not create from nothing. It creates from patterns. It studies huge amounts of examples, learns relationships within those examples, and then generates something new based on what it has learned. It is not magic. It is not human imagination. It is not a mind sitting inside a machine. It is mathematics, data, and probability working at enormous scale. But that does not make it unimportant. A camera does not have eyes, but it changed how we remember. A printing press does not have a voice, but it changed how ideas spread. A piano does not have emotions, but it can help humans express them. Generative AI may become another tool in that long history. A tool that changes how we write, design, teach, film, communicate, and create. The history of generative AI is not just a story about machines. It is a story about human curiosity.
For decades, people asked whether machines could think, learn, recognize, and create. Generative AI may feel new, but its roots are deep. It carries the history of mathematics, computer science, language, art, music, and human imagination. And now, we are living through one of its most important chapters. The question is no longer only, can machines create? The question is, what will humans choose to create with them? Because in the end, generative AI is not the artist. It is the tool. The vision still begins with us. Thank you for watching.